Picture this. It is like 2 in the morning. A major checkout cart feature on your company's app just crashed during this massive automated test run.
Oh man, that is literally the worst nightmare.
A server in Ohio says the request timed out. A database in Ireland says it never even got the payload. And your external payment vendor is throwing some totally obscure error code that no one on your team has ever seen before.
Yeah, and now you have tens of thousands of lines of just chaotic system logs to read through.
Exactly. And your engineering manager is messaging you like every 5 minutes asking when the build will be fixed. So today we are looking at a groundbreaking solution to this very specific kind of modern torture.
We really are. We are diving into a newly accepted paper for the prestigious ICSE 2026 conference.
Yeah, it details a system from Google AI called Auto-Diagnose. And our mission for this deep dive is to explore how Google is using a large language model to basically act as this tireless co-pilot.
Right. A co-pilot that instantly diagnoses incredibly complex integration test failures. And I mean, even if you aren't a software engineer, this deep dive is going to reveal some really fascinating insights about how AI is fundamentally changing problem solving.
Absolutely. But, before we get into the AI solution itself, we kind of have to understand why integration tests are such a notorious nightmare compared to just regular unit tests.
Well, yeah, because a unit test is highly localized. You're checking if one specific isolated piece of code behaves correctly in a vacuum.
Like checking if a spark plug works on a workbench.
Exactly. But an integration test is putting that spark plug into the engine, driving the car down the highway at 80 miles an hour, and then suddenly the engine just catches fire.
And you have to figure out which of the thousands of moving parts actually caused it.
Right, it's a completely different beast. Modern apps are distributed networks made up of hundreds or thousands of microservices, all talking to each other constantly.
Which means when a test fails, the root cause could be almost anything.
Yeah, and the paper actually cites this internal Google survey of over 6,000 developers. It reveals that diagnosing integration test failures is a top 5 complaint across their entire engineering org.
Wow. Out of everything they do, it's in the top 5.
Oh, absolutely. It can take developers anywhere from a full hour to an entire workday just to find the root cause of a single failure.
Just finding it, not even fixing it. I mean, think about your own job for a second.
Yeah.
How much of your day is spent just finding the problem rather than actually fixing it?
It is a massive drain. You have all these massive semi-structured logs and a terrible signal-to-noise ratio.
Yeah, the cognitive load is just immense. So, okay, let's unpack this. How do you actually automate finding that needle in the log haystack?
So the expert team at Google built this really elegant 4-step process for auto-diagnose. First, a failed test triggers a pub/sub event.
A publish and subscribe event. So basically a digital flare goes up the millisecond, a test crashes.
Exactly. And then the system gathers INFO-level logs from multiple data centers. It pulls from the test driver and the system under test.
Wait, NFO level logs? Why not just error logs?
Well, because error logs usually just tell you that a crash happened.
Yeah.
The INFO logs have all the routine diary entries of the system before it crashed. That's where the actual context is.
Oh, right. That makes total sense. You need to know what was happening right before things went wrong.
Right. Then we hit the most crucial step. It takes all these separate log streams and merges them, sorting everything strictly chronologically.
So it puts them into a single linear timeline.
Exactly. And finally, it feeds this perfectly ordered stream to Gemini 2.5 Flash and outputs a markdown summary with the root cause.
Okay, but wait, I have to push back here. They just dump massive raw text logs into a general LLM.
They do, yeah.
Doesn't the AI just hallucinate and make up a reason for the failure? I mean, we all know generative AI loves to confidently invent plausible lies.
That is a very valid concern, and it's where the brilliant technical constraints come in. They don't just dump the text in. First, they use a very low temperature setting.
Like dropping the creativity dial.
Yeah, right, specifically down to 0.1. It makes the outputs deterministic and debuggable. But most importantly, they use what are called hard negative prompts.
Hard negative prompts. So what does that actually look like in practice?
It forces the model to abstain from guessing. It explicitly tells the AI, hey, if the logs do not definitively contain the answer, you must state that the information is missing.
Oh, wow. So they give the machine a safe escape hatch to say, I don't know.
Precisely. And this leads to the most surprising revelation in the entire paper. There was zero fine-tuning on Google's internal code.
Wait, really? 0 for Google's proprietary code base.
0. It is purely prompt engineering on a general-purpose model.
I mean, that is just wild. I find that so hard to wrap my head around.
Well, it works because language models are exceptionally good at sequence prediction. The AI doesn't need to know how the network is coded. It just needs to recognize the logical causality of failure in the text.
Right, like process A requested memory and process B crashed right after. That is universal logic. Okay, but a clever prompt in a controlled lab is one thing, right? How does this actually survive the chaotic reality of Google's massive daily operations?
The deployment data is staggering. They've had Auto-Diagnose active in production since May of 2025.
So it's fully battle tested.
Oh, definitely. They did manual evaluations of 71 real failures across 39 teams, and it showed a 90.14% accuracy rate.
Over 90% accuracy on the hardest bugs generated by 39 different teams?
Yeah, and in production, it has processed over 52,000 distinct failed tests
Wow.
across 91,000 code changes by nearly 23,000 developers.
That scale is just hard to fathom. But you know what really matters is the turnaround time. We talked about developers losing entire days. How fast is the AI?
The median latency, so the P50 time to deliver an answer, is just 56 seconds.
56 seconds. You go from staring at a scrolling matrix of text for an entire day to getting a cited answer in under a minute.
It fundamentally changes the workflow.
It really does. And I want to highlight a massive UX win mentioned in the source too, because Auto-Diagnose isn't some separate dashboard developers have to log into.
Right, which is a brilliant integration strategy.
Yeah, nobody wants to learn a new interface. So it publishes its findings directly into Critique, which is Google's internal code review tool. It literally meets the users exactly where they are.
And what's fascinating here is how the developers reacted. Because developers are notoriously harsh critics of automated tools.
Oh yeah, they hate everything that adds clutter.
Exactly.
Yeah.
But Auto-Diagnose received a not useful feedback rate of only 5.8%.
That is incredibly low.
It actually ranks in the top 3.78% of all tools publishing in Critique. It's 14th out of 370 tools.
So it's accurate, and it's highly trusted. But okay, here's where it gets really interesting. Nothing is magic, right? So what are the catch and the limitations?
Well, the paper breaks down a few major hurdles. The first is the classic garbage in, garbage out problem.
Meaning the AI is only as good as the logs it's reading.
Exactly. Auto-Diagnose is entirely dependent on the quality of the system's instrumentation. If the architecture is sloppy and fails silently, the LLM is blind.
And because of those hard negative prompts, the AI will correctly abstain and just say, I can't determine the root cause.
Right. It highlights a continuing need for disciplined software engineering.
Yeah.
Then there is the trust factor. Developers still need to verify the AI's claims.
Because you can't just operate on autopilot.
No, it requires a strict human-in-the-loop approach. The human remains the pilot in command.
Right.
And finally, there's the challenge of generalization. Adapting this outside of Google's specific massive infrastructure will require some serious tweaking.
Because the way logs are gathered and merged is highly optimized for their specific tech stack.
Exactly. Replicating this success elsewhere means building a completely new data ingestion pipeline from scratch.
So what does this all really mean for us? I think the takeaway is that this isn't about AI replacing engineers. It is about augmentative AI in DevOps.
Yes, absolutely.
It eliminates the soul-crushing busy work, and it allows humans to get back to the creative part of actually designing better systems. To kind of sum up our journey today, we explored how a general LLM without any special training is acting as a 56-second automated detective for Google.
Yeah, transforming days of frustration into a minor hiccup.
It's amazing. But I want to ask you something, because the paper hints at future features like test pilot and predictive analysis.
Yes, and if we build on that, there's a final lingering thought I have.
Oh yeah, let's hear it.
Well, if an AI can read thousands of lines of logs and diagnose a complex failure in just 56 seconds, how long until we cross the threshold from auto-diagnose to auto-heal?
Oh man, that is a wild concept.
Imagine a future where by the time a developer even pours their morning coffee, the AI has already noticed the failure, written the patch, tested it, and deployed the fix entirely in the background. Are we moving toward an era where our software essentially develops an autonomous immune system?
An autonomous immune system. That is something you all should definitely explore on your own. Thank you so much for joining us on this deep dive. Keep questioning how AI can solve the boring but painful bottlenecks in your own work.